Let's look at the final section of factoring polynomials. We're going to look at trinomials still that are in the form of ax squared plus bx plus c. But today we're going to look at when that a or that leading coefficient is 1. And so it's an understood one. Look at your examples really quick there. You can see they all start with x squared. So here's our steps. We're going to always look for a GCF or a negative to factor out first. The GCFs will help make our polynomial smaller. And then we always want our leading coefficient to be positive. So if you ever see it leading with a negative, pull out a -1 or a negative value to make that leading coefficient positive. Step 2, we're going to find the factors of C that add up to B. So let me pause right here and say that you can use the method that we did before and multiply A times C and split the middle and make 4 terms to use grouping. But you don't have to do that here. If your leading coefficient is 1, you can just look for the factors of C that add up to B, and that's how we will build our binomials. So let's get started so I can show you that in action. Number 1 is x squared plus 7x plus 12. So if you really want to, there is an understood one here, and you could multiply this. 1 times 12 is 12. Now notice that's still the value of our constant C. So factors of 12, we've got 1 and 12, 2 and 6, 3 and 4. So which set of those are going to add up to a 7? Obviously 3 and 4 here. So I don't need to split the middle and rewrite this. You don't have to do that. You can if you really want to, but look how quick this is going to be. If I did continue and find my GCFs, I'm going to end up with an x GCF times x plus 3. My second GCF is 4, and I have x plus 3. And my final answer is x plus 4 times x plus 3. So I went ahead and showed like the grouping method, but you don't need to do that. If I had just taken 3 and 4 and built binomials, I would have been done. X plus 3 and x plus 4. Just throw them in your binomials and you are done. You don't have to do this whole grouping method up here. You can just skip straight to your final answer. And the order doesn't matter. So you can see I wrote first x plus 4 times x plus 3, but remember multiplication is commutative, so the order didn't matter. If you want to put x plus 3 and then x plus 4, it's the same thing. So let's do it again on number 2, x squared plus 9x plus 20. If you really want to, you could multiply 1 times 20, but that's still 20. And I want the factors of 20 that are going to add up to 9. And this is just my scratch work over here. We've got 1 times 20, 2 times 10, 4 times 5, and I think that covers it. So which ones would add up to 9? A 4 and a 5. So I can just throw it in, x plus 4 times x plus 5. Now, I didn't show it on the last problem, but you can check them. Remember, you can FOIL them out. If I wanted to check, I'm going to FOIL. First, outer, inner, last. First, x times x is x squared. Outer is going to give me 5x. Inner is going to give me 4x. And last is going to give me 20. When I combine those like terms in the middle, I get that 9x, and I'm back to my original problem. So easy. I know I left the last one, the easiest one, for the end, but that was so you could get through all the other types of factoring. Let's move on to number 3. X squared minus 6x plus 8. Again, if you really wanted to, 1 times 8, but that's still 8. The factors of 8 that add up to a -6. All right, let's see. 1 times 8, we have 2 times 4, and that's it. So how could I multiply two numbers together to make a positive, but I need them to add up to a negative? So if I need them to add up to a negative, let's make them both negatives. I'm looking at the 2 and the 4. If I have -2 plus -4, that's -6, right? -2 times -4 is +8. Two negatives make a positive when you're multiplying. -2 plus -4 is -6. So some teachers like to show if your second sign is positive, your signs are going to have to be the same. They're either both going to have to be positives or they're going to have to both be negatives. And then you know which sign they're going to have to be by looking at the first one. So if you have a positive as your second sign, that means my signs are going to be the same. And then this tells you, the first sign, the minus, tells you what sign that's going to be. So let's go back and let's fill this in. Our binomial is going to be x minus 2, x minus 4. And you can check it. First, outer, inner, last. First is going to give us x squared. Outer is -4x. Inner is -2x. And last is 8. When I combine those like terms, I am going to get negative 6x and the plus 8, which is our original problem. So binomials, x minus 2 times x minus 4 is our factored form. Number 4 says x squared minus 3x minus 54. I'm going to look for the factors of negative 54 that add up to a negative 3. 54, all right, it's probably not 1 and 54. We've got 2 and 27, 3 times 18. Now, if you have trouble finding these, just start dividing by numbers and see what we get. What about 4? Will 4 divide evenly? No. 5 won't divide evenly. 6 and 9. 6 times 9, and I think that's going to have us covered because 7 and 8 will not go into 54. So which of these values, which of these factors do you think we can manipulate so that they will add up to a negative 3? My eyes are drawn to that 6 and that 9. Now I need them to multiply to make a negative. So again, let's look at our signs. That second sign, it's negative. So my signs in my binomials are going to have to be different for them to multiply and make a negative. Now I need them to add together and make a negative. So your negative sign here to add up to a negative 3 is going to have the same sign as your largest number. So let's try 6 times negative 9 is negative 54. And let's try 6 plus negative 9 is negative 3. Does that fit? Fits. All right. Binomial x plus 6 and x minus 9, and you're done. Let's try again with number 5. X squared plus 2x minus 35. I need the factors of negative 35 that add up to a positive 2. 1 and 35. 2 does not go in it. 3, 4. What about 5 and 7? I think that's going to be our winner. I need different signs because our second sign in our polynomial is a minus sign. So I know they're going to be different so that they multiply to make a negative. And I need them to add up to a 2. So I'm going to put a positive on my largest number. So that means I'll need a negative on the 5. Let's check it. Negative 5 times 7 is negative 35. Negative 5 plus 7 is positive 2. Does that fit? Fits. All right, x minus 5, x plus 7. And number 6, x squared minus 2x minus 24. I need the factors of negative 24 that add up to a negative 2. That second sign is a negative, so I know my signs are going to be different here. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I think that covers it. So I think the 4 and the 6 are going to work here. We're going to need it to add up to a negative number, so I'm going to put negative on my largest one, and let's check. 4 times negative 6 is negative 24. 4 plus a negative 6 is negative 2, and that's what we need. So let's throw it in. X plus 4, x minus 6, and done. So the second part of our notes I've titled special cases. So these are polynomials that have formulas that help us factor them, because without the formulas, honestly, I don't know how we would factor them otherwise. In Algebra 1, you learn about difference of squares. Now think about what I'm saying. Difference means subtraction. So we are subtracting what? Squares, perfect squares. So let's also list our perfect squares here to the side. Now our perfect squares, I mean 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, then you have 25, 36, 49, 64, 81, 100, 121, 144. Let me go ahead, and 13 is 169, 14 is 196, and then 15 times 15 is 225. Okay, so we reviewed those earlier in the year. You might be a little rusty, but you might want to write those down on your notes or have them somewhere, because we are going to be looking for those perfect squares so we can factor these. The factored form, the formula up here says if you have a perfect square, a value has been squared minus a b value has been squared, then the factored form is a minus b times a plus b. And again, your order doesn't matter. Actually, I end up writing usually the plus sign first, but the order there does not matter. Let's look at number 1 here. I've got some additional notes here. It says always, always, always check for a GCF. And then you cannot factor a sum of squares. I've given you the example. You cannot do x squared plus 9. They have to be subtracting. So number 1 says x squared minus 16. You want to see, hey, is there a GCF? No. 2, is it a special case? Are these perfect squares? Yes. We have x has been squared, and then minus 4 has been squared, right? The square root of 16 is 4. 4 squared is 16. So my A value here is x, my B value here is 4, and guys, these are my favorite. I really do love these. So if you struggle on these, I'm going to be like, no, because I really do enjoy factoring these. So x squared minus 16 is going to factor down into x plus 4, x minus 4. Done. Done. I really don't know how we would do it without our formula. And let me prove it to you. Some of y'all are like, Ms. Brian, that's not the factored form. Let's FOIL it. So first, I'm going to do first, outer, inner, last. My first, x times x is x squared. My outer is going to give me negative 4x. My inner is giving me positive 4x. And last, 4 times negative 4 is negative 16. Now, what happened? We got a negative 4x and a positive 4x there in the middle that are going to cancel, and there's where that difference of perfect squares is. It's because we had opposite signs that are like terms in the center cancel out and are gone. So final factored form of x squared minus 16, x plus 4, x minus 4. Let's do it again. Number 2, x squared minus 49. Look for a GCF. Check and see if these are perfect squares. They are. Our A value here, x squared. So x has been squared, and minus, we have 49, perfect square. The square root of 49 is 7, so 7 was squared. So my factored form is x plus 7, x minus 7. Done. Number 3, 25x squared minus 36. We've got perfect squares here. 25 is a perfect square. X has been squared, and therefore is a perfect square. And we have 36, a perfect square. So what has happened here? The square root of 25 is 5. The square root of x squared is an x. So 5x was squared minus the square root of 36 is 6. So 6 was squared. There's our A value and our B value being squared in a subtraction problem here. So my factored form, 5x plus 6, 5x minus 6. Done. And of course, you can FOIL and check those to see if you get back the original problem. Number 4, 144x squared minus 121. Everything here is perfect squares. 144 is a perfect square. 121 is a perfect square. They're listed up there in pink. We've got 12. The square root of 144 is 12. X was squared minus 121. The square root of 121 is 11 was squared. So our factored form is 12x plus 11 and 12x minus 11. Again, you can FOIL if you want to check. Number 5, 5x squared minus 125. Wait, 5's not a perfect square. This is weird. Wait, what are we always supposed to look for? A GCF first. So what do they have in common? That 5. You could remove a 5 as your GCF, and 125 divided by 5 is going to give us 25. Now things are looking a lot better. Now remember, do not lose your GCF. We are factoring. We're finding the original pieces that were multiplied together to make this. If you magically lose that 5, we'll never get back our original problem. So keep 5, and then let's continue to factor x squared minus 25. Now we have a difference of squares, which is going to factor in x plus 5, x minus 5. And you can check all of that. You can multiply it all back together. I would suggest do the FOIL piece first, multiply your binomials together, and then distribute that 5 across, kind of just going backwards of how we worked it. But that is our final answer. 5 was our GCF times x plus 5, x minus 5. So that is your final lesson of factoring polynomials. We've looked at every different type. We started with GCFs. You should always look for a GCF first because they can be in any kind of polynomial, but we factored out GCFs. We then looked at if there were 4 terms, we used the grouping method. Our third lesson on factoring was if there was a leading coefficient on our trinomial greater than 1, we made it into 4 terms so we could use grouping. And here we are wrapping up. If I have a leading coefficient of a 1 on my trinomial, I can really just look for the factors of my last term that add up to the middle and then just throw them into my binomials and make it quick and easy. And then wrapping up finally with that special case of difference of squares. Remember, you cannot factor a sum of squares. So if you ever see that, probably on a testing or a benchmark question, you can't do that. But it is my favorite, a plus b, a minus b from our difference of squares. So practice, practice, practice. Make sure you are learning these because you're going to continue to use them throughout our lessons and then on into Algebra 2. So it's worth your time and your investment to learn how to factor. Let me know if y'all have questions, and I'll see you in class.